right, for something very different now. I know the topic on weather is probably quite a tricky one to teach to your students, isn't it? And I kind of looked through the curriculum, because I didn't go through A-levels myself, so I kind of, when I was asked to teach something for A-levels, I kind of went, well, I haven't done A-levels myself. So I kind of went back to the books. I kind of went, right, this is 1992, 1980 something. I kind of, if you're 16, 1992, that's like prehistory, right? So this doesn't really mean much to a lot of our students. So what I wanted to do is kind of do maybe a slightly more updated case study and something that's maybe geographically a little more relevant to our students. So when I look at the North Atlantic, we've got Africa here, we've got Europe there, and then we've got North America there. If you look at that, you can see that our North Atlantic is dominated by two main weather systems. We've got the hurricanes forming here, and there's two hurricanes there. And then around our regions, we have the mid-latitude frontal cyclones. And I think that's two topics that you probably cover within the A-level curriculum. So that's usually what we get. So when we look at Ireland, so we're right there, and you see a weather system like that, what should it be? A mid-latitude frontal cyclone, right? That's what is dominating our systems. Now, if I go back a few days back in time from this satellite image, and this weather system is actually sitting there about a week beforehand. So is that a mid-latitude frontal cyclone? It's coming from the wrong direction. So this is Ophelia. Okay, so this is when the hurricane hit Ireland. So I'm going to talk about Ophelia because it brings two things together. It brings back the hurricane, how it's developing, but it also was influenced by a mid-latitude frontal cyclone. So it brings the two things together, and it's nice to compare things. What I wanted to do is give you resources of what you can use in the class. So if, let's say, in August or September another hurricane hits, you can actually then use maybe that current hurricane to develop your own case studies. So it was a record breaker because it was the furthest east a hurricane had ever developed. It was actually category 3, which is quite strong for a northerly hurricane. And it continued as a hurricane for quite a long time period. So we're looking at October 2017, which hopefully for students is not that long ago. They probably remember that the schools were closed for 2 days. Okay, so what do we need for hurricane formation? So if you think back about what you teach to your students, they should be able to come up at least with 2 or 3 things you need for hurricane development. There's 5 things you need for a hurricane. And let's see if that was the case for Ophelia, or what was weird about it. First of all, you need a disturbance in the atmosphere. Usually these disturbances happen in Africa. We have some thunderstorms. They travel with the trade winds. They hit the ocean. The ocean has to be roughly 27 degrees or warmer for a hurricane to form. That's the fuel of the engine. If there's not hot water, then you will not get hurricanes forming. You need converging air. What that means is you need to have air coming together. So we have air coming from the north, so the trade winds from the north, you have trade winds from the south. 2 things that meet together can only go one way, up. Right? So you need to have convergence of the air to go up, and that system starts to kind of move in that direction. Rotation, so the whole thing needs to start to spin. So that's the Coriolis, which you probably do with your students as well. So you can't have them at the equator because we have no Coriolis effect at the equator. So you need to be slightly further from the equator. And you need to have slight wind shear. So you need to have something to push that system through. If the wind is too strong, then everything gets pulled apart and you won't have a hurricane. If it's too slow, then it starts to rain on top of that converging air and the whole thing shuts down. So that's what you need. So normally we get our hurricanes kind of just north of the equator. The red area is where Ophelia was born. There. Well, you can already see that that's not quite what we expected. So we're right here. So we don't actually have converging air either. We have air moving away from that area. So it really was an odd one out. So I've given you, or Paul should have given you, a little Word document with the timeline, because I looked at some examples from the curriculum, and there's always a timeline. So I've given you the timeline. So I'll go through it quite quickly before I show you some data. So 7th, 8th of October, a disturbance grows. Remember, that's the first thing we need, disturbance. Southwest of the Azores. 9th of October, this disturbance becomes a tropical depression. Sea surface temperature is just about 26, 27 degrees. The 9th of October, the depression strengthens and it becomes a storm named Ophelia. And the storm is trapped between a subtropical ridge on the south and a mid-latitude ridge on the north. And because it's sitting between two ridges, that's affecting the shear. So it's not moving too fast away from its area. It's kind of trapped between there. And it becomes a deep convection. So although the water was coolish for a hurricane, higher up, the air was even cooler. So you have moderately warm ocean water, but very cold air sitting above it. So a temperature gradient, which means that air wants to move from that hot ocean water up to the cold area. So there's something there to keep it moving. Tuesday, we get strong tropical force winds. Wednesday, it becomes a hurricane, so the winds become stronger, and the Ophelia sits there for about 2 days. Thursday, that's the maximum wind strength for Ophelia. We're looking at about 167 kilometers per hour. Friday, it's starting to move in a northeasterly direction, and I'll show you why. This is where the jet stream comes into. It basically gets trapped in the jet stream and starts to move northeast towards Ireland. On the Saturday, it becomes a category 2, and the forecast is it's not going to strengthen. It's fine, we're all good. By the evening, it's actually turned into a category 3. Sunday is where it's now taking aim on Ireland. This is where we start to get all the weather warnings. Ports are getting closed, airports are getting closed. So this is, you can read this yourself. There's a lot of tweets going around the world at that point. And then Monday is really when it hits Ireland. By the evening, it's gone over, it's gone past, and that's the end of it. So I'll now show you what's happening. So we've gone through it, so hopefully it's in your mind. And if you have a mobile phone or you have an iPad, you can try this yourself. This is a great resource for your students as well. So there's this website, earthnullschool.net. I'll click on it. Don't know, has anyone ever used it? Okay. So this shows you, I'll go to the North Atlantic. This shows you a model of the wind anywhere on the planet live. Okay, so this is the wind now modeled for the entire globe. So you can see there's a mid-latitude frontal cyclone sitting over Scotland at the moment. So this is a great resource to actually show things visually to your students. So what you also can do is you can go back in time. So you go to the little calendar, we go to 2017, go to October, and I'll start, let's say, on the 5th of October. Okay, apply. Okay. You can also click on it, so let's say there, and you can start to actually see values coming up. So it says the direction of the wind and how fast it's going. I'm actually going to try, so I've given you where Ophelia was formed, so 39,500, 31. So if you go to the top, you can actually change that. 500, no, I think it was 31. 800. Okay, so it's now putting the dot on where Ophelia was formed. So what you can do is you can move here with these little arrows, you can forward day by day, you can look at all sorts of things. So I'm just going to look forward and we're going to see when Ophelia occurs. So that's the 5th, 6th, 7th, okay, there it is. Okay, so you can start to see Ophelia forming there. Okay, and the beautiful thing about this, I'll keep going a bit further, is you can also look at, for example, what the temperature was in the ocean. So if I click on ocean, and look at the sea surface temperature. So you've got all that data there for you to play with. So rather than just looking at the theory, you can now actually get the students to use data and analyze things themselves, which I think is missing a little bit from the curriculum. And here it says, right, at that time, it was 25.6 degrees. Okay, so everything is in there. So in a minute, we're going to look at some other data, so particulate matter, for example. So this is fantastic. You can use it for anything that's you have data for. Okay, so what was so strange then about Ophelia? And there's another lovely resource here. So you can go to this website and you can download tracks of all the hurricanes and tropical storms from the last 20 years. You can plot them in Google Earth, or your students can plot them in Google Earth. You can click on them. On each of these dots, it will have information about how strong the hurricane was, which direction it was going into. So this is Hurricane Irma a few weeks before Ophelia. This is Hurricane Ophelia. And immediately you can see it's going in the wrong direction. So anytime you plot hurricanes, they form here and they hit America. This one, you plot it, it kind of sits around there and then it goes up that direction. It's also forming very high up. So it's being formed in areas where you normally don't have them, and it's traveling in the wrong direction. So let's have a look now at the timeline. So if you keep a track on the timeline, I'm actually going to set up the data here, and I'm just going to scroll through it. But again, you can do this with your students. They can do that themselves. Right. So what I've done is I've taken from the previous one I've done a little time series. So I'm going to go forward in 12-hour steps. So that's the date here. So start on the 5th, and I'm going to scroll through. We're going to see the birth of Ophelia. So there's nothing there at the moment. Okay, there's a little disturbance there, and that's where you first start to see a little disturbance. On the 7th, that's it there, formed, a tropical storm formed of the 7th. The 8th, 9th, the 10th, and it's just sitting there. It's not going anywhere, just sitting there. 11th, okay. Towards the 11th, what you can now see here is a mid-latitude frontal cyclone is being formed. Look at the size of it compared to the hurricane. Right, can you see which one's more powerful? That one there, okay? Although we were very worried about this one is actually a lot bigger in size. So if I keep scrolling, this one's going to move in that direction, and you can probably guess what's going to happen. So if I go and I move across, can you see it? That's the front here. Its long tail. It's pushing in that direction. As I go down, the front is basically sweeping up the hurricane right at the edge, and it's sweeping it in that direction. Okay, so it's now part of the front of the mid-latitude frontal cyclone. Travels up. This is where it then hits Ireland and then disappears fairly quickly. Okay, so if we look at the temperature, so I've put the temperature there, you'll see it's 26.7 degrees, it's just right on the edge. Usually it needs to be 27 degrees. As we start to go towards the 8th of October, you see the temperature's already starting to drop, 26.1, 25.9. So actually, it's too cold for hurricanes to form. Yet it managed to do it. We're going to look at the air temperature in a minute, and you'll see the temperature continuously keeps falling, falling, falling. So it really was exceptional for it to form. Okay, so as well as the wind, we can look at the temperature high up in the air. And this gives us an indication of what the jet stream is doing. So this is the position of the jet stream. So anything to the north of it is cold air. Anything to the south of it is warm air. So this is the 5th of October. Look at how far south the jet stream is going. So this is cold air sitting right in that same position. So the jet stream is very far south. So you have warm ocean but very cold air sitting right on top of it, which causes convection. So that makes that hurricane what it is. You also can get very good satellite imagery, and you can see that front here. So you can see the clouds, you can see the front. So let's scroll through that, and let's see what happens to that jet stream as the hurricane develops. So 5th, we have nothing yet, and then the 7th we get the disturbance. The jet stream is fairly usual. Okay, there we go. 8th, 9th, nothing unusual. This is where Ophelia's first start to appear on the weather charts. You can get those for free as well. Okay, as we keep going, 11th is where we start to develop that mid-latitude frontal cyclone. The 12th, keep going. So this is now the 13th. See how that jet stream is now going south again? Ophelia is sitting there. So keep an eye on this. This is the front here as well. Do you know where the name front comes from, why people use the name front? It goes back to World War I, I think. World War I, when they first started to make maps like that. So during the war, people were just thinking about fronts, right? So this is basically the division between cold air and warm air, and you can imagine a front sitting in between that. So Ophelia is sitting here, right on the front, and it just cannot get past it. So you can just even literally think of it as a wall sitting there. So if we keep going, right, can you see here? It's getting stuck in that front. It just cannot go that way. There's only one way it can go, and it's being swept up in our direction. And then it becomes part of it. It actually gets completely taken into that frontal system and moves up north. Okay, so when did it arrive in Ireland? So this is the 14th of October. That's part of that mid-latitude frontal cyclone. So we have Spain here. And this is when it first appears on the satellite imagery, and it's already part of that bigger frontal system. It moves up, 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 up. It's starting to get darker now in Eastern Europe, so soon we're going to lose it. It's nighttime, and the next day is when it hits Ireland really early in the morning. You can see now it's still nicely the eye, and as soon as it hits land, it loses its energy, and it just falls apart. Oops, come back to the start. So all of those things that I've shown are all free. Okay, so I've given you the links, all the weather maps you can go back to whenever you want. Jet stream data, it's all there for you to use. So what were the impacts? I think we were probably all a bit underwhelmed by Ophelia. Well, at least I was. Everything was closed, but it didn't seem that bad. But it was pretty bad when it first hit Ireland. And if you start looking at the map of the wind gusts, and you can see it was nearly 200 kilometers an hour when it first hit Ireland. But then as soon as it hits land, and with all hurricanes the same, as soon as it hits land, it loses that fuel. It needs that fuel from the ocean. So as soon as it hits it, it dropped down fairly quickly. So by the time it reached the north, it was still fairly strong for the gusts of winds, but it was more like a big storm. So you can get some information about the actual values for that if you wish. The pressure. So usually pressure systems, we're looking at about 1,000 millibars if we have a big storm. Ophelia was 963 hectopascal. But compare that with, let's say Katrina, which was quite a little bit lower. So it's not a big hurricane compared to the ones that you probably find in your case studies. But for our latitudes, that was really quite low pressure system. Physical. Oops. We had very big waves, up to nearly 30 meters high. So this was taken during Ophelia in Cornwall, so a bit away from the main low pressure system, which meant for low-lying areas, major flooding. Oops. Another peculiar thing that happened is in the south of England, they had these red skies. And this is Ophelia here there. You can see at the same time there's a lot of Saharan dust being flown into here, and there were also a lot of forest fires. Again, if you go to your data, you can get students to look at that themselves. Oh. So I can go, let's say, to the 16th of October, and I want to look at the particulates at that time. Okay. Needs to update a bit. There's Ophelia there. And can you see the amount of smoke that's in the air at that time? So I'll go forward a little bit. Oh, no, that was a big one. Okay, so these are forest fires in Portugal, bringing up a lot of smoke and dust into the air. Ophelia is sitting here. Oop, right, pushed on something. Ophelia is sitting here. Don't push that button. Ophelia is sitting here, and it's sucking in all the dust into its eye and bringing it to the south of England. And that's scattering the light late at night and early in the morning. So that's why they had those red skies looking at when Ophelia was just hitting Ireland. Casualties, 3 people died, mainly because trees fell on cars or someone was stupid enough to take a chainsaw out during hurricane. Infrastructure, about 400,000 households lost power supply, again because trees fell on power lines. Roads were closed, airports, harbours closed, schools were closed for 2 full days. So when we look at the economy, the media reports that we're looking at probably in total about $20 million of insurance claims for the north and the south of Ireland. And the total cost to the nation is estimated to be €1 billion for basically 1 day of disruption. So was this unique? No, it wasn't. It has happened in the past. 1961 there was ex-Hurricane Debbie. So this is not the first time this has happened. And actually when we look at the strength of Debbie, which is in orange, Debbie was actually stronger. But there's a lot of information about Storm Debbie, so you can even do a comparison between the two. The thing is, there was no social media when Debbie hit, okay? So it's a very different narrative around it. So a lot more people died, I think, I can't remember, about 13 or so. And then an airplane crashed as well, so it was a lot more dramatic than Ophelia. Is it climate change? As soon as we heard about Ophelia, the media was on it like a hawk. This is climate change, right? Global warming, here we come. All the newspapers you looked at, Ophelia is what climate change is going to look like. This is what's going to be like in the future. The shape of things to come. Mass frenzy, is it really? Okay, so the Irish Academy had a look at the data, and they looked at the sea surface temperature a few months before Ophelia and then during Ophelia. And yes, it was warmer than usual, so reddish colors, when Ophelia was born, but even just 3 months earlier, it was actually colder than usually in that spot. It's just the way things came together, it seems like. So yes, we had a hurricane forming, but that mid-latitude frontal cyclone just swept it up and pushed it up further north. That said, New Scientist also had an article saying this is what's going to happen in the future. In 2013, a researcher predicted that this was going to happen in the near future. So what he's saying is, if the ocean does get that little bit warmer and hurricanes can form, then they will form further north, and the jet stream is going to sweep them up and bring them to Europe. Okay? So there is something in it. It is likely that it's going to happen more often if the water gets warmer, and you have to have that jet stream being able to bring it up. So there's still a debate whether this is an expression of global warming or not. But if global warming is going to continue, then it's more likely that hurricanes will reach Ireland more often. So I was thinking of what you could do, for example, with your students. If you go to Twitter, which is very interesting, because I like the idea of how social media is influencing our ideas of what's really happening. So the combination of science and social media, I think, is something that's easy to explore. If you, for example, go to Twitter, I don't know if you know that you can do an advanced search in Twitter. Has anyone ever used it in their classroom? No? So, for example, I'm going to look for Ophelia. And I'm going to start looking, so 2017. Let's say I'm going to start on the 8th. And I'm going to do it for a week. Till the 15th. Right, so you get all the information of what people posted up on Twitter about Ophelia, which is a lot of information. But you can actually, if you start from the start, you can start to build up a picture or almost have a diary of when it started to hit Ireland and all the things, all the events that were happening, which I think makes a nice story. But there's also a lot of very funny things on there, which kind of makes it a little bit more entertaining. You can also start to look at all the newspapers and all the drama that was going. It was going to be the end of the world, but it's really good to kind of analyze what the predictions were and then compare it with what I just shown you, the wind data, for example, and see, is that really what happened? So there's a lot that you could do. Useful resources. If you go to the National Hurricane Center, there is a PDF for every single hurricane that has ever been in the North Atlantic, any tropical storm. There's a report. KMZ is what you just put it straight into Google. If you use GIS in your classes, there's shapefiles, everything is in there. If, let's say, you start to teach this again September, October, and there's a hurricane, there's a live tracker, so you can get students to track what's going on. A lot of very useful information. And then I've given you plenty of web links, all with free data, if you decide to make your own case study. Let's say something does happen in the next few years, and you want to use it in your class. Any questions? Go ahead.